Hello to everyone. I'm Andrea Menghini from GeoMax Support and Training Team. And today we will see a live example of a traverse calculation directly on site. I just want to start with a quick overview about this functionality through a PowerPoint. So since the service pack number 2 of 2020, we have the possibility to calculate directly in field using the toggle functionality and open a closed loop traverse and a closed traverse directly on field. How we can use this functionality? Traverse calculation is a specific tool that requires to set up a traverse directly in field, and through the measurement of some point, of course with the accurate measurement of the point, we can use a reference point, and we can use reference point to calculate a closed traverse, or we can directly use a closed loop traverse and perform the traverse calculation. Of course, checking all the function and check also all the results directly on field. Okay, this is just an example about the two functionality that we have here. On the right side, you can see a closed loop traverse. So in that case, we need to close the traverse on the starting station. The second example is a closed traverse on which we need to refer the traverse on the starting points, on the starting station, on the closest station to a reference point. And what does it mean in the specific, the closed traverse? So in that case, we need to start the traverse. For example, the F2 point is the starting station, plus also on that point, we have also a reference point already measured. Then from the reference 2, we can directly move forward and measure the station ST1. From the ST1, we can refer to F2, so we can look forward. We can refer to station number 2, and we measure the next station, which is the F4. And from the F4, which is referenced to ST1, we must have also a reference point. So on the closing point, on the starting point, we must have two reference points. The second example is for a closed loop traverse. So in that case, we can perform the calculation in two different ways. So we can start with a normal survey measuring a backside point. That can be a reference point or whatever you want. Also classical, and we will see then the azimuth orientation. Then from the station 1, we need to measure the ST2. From the ST2, we can refer to the station 1 and measure forward the ST3. Then we can, of course, move to the last station, that in that case is the station number 4. From the station number 4, we need to measure the station 3, and then the first station, which is the station number 1. Then we need to move again to station number 1 and measure with the same orientation the backside and measure the station 4. So in that case, we need to in the station number 1, we need to refer to station number 1 twice and measure also the station 4. The other case is that from the station number 1, so for the starting station, we can measure the next station, so the station number 2, but also the closest station, that could be the station number 4. So in that case, we don't need to move again to the station number 1, measure the same orientation, and measure the last station. Then we will see also live the calculation, but just to have a quick overview from the software side. This is the example that I just showed you in the previous slide. And from the calculation, we can, of course, check the angular, linear, and elevation error using, for example, the entering the coefficient value for linear error, but also the tolerance value for the elevation error. And from the tolerance calculation for the angular error, for the linear error and for the elevation error, we can also select if we want a fixed value or the coefficient square, or if you want to distribute on the vertices or on the traverse length of the traverse. Okay, let's move directly to the site. I'm now with a support team.
Hello guys, welcome to this new webinar today.
Oh,
ready to go, Andrea.
Yeah, perfect. So we can start a new project. We can call it traverse live. Accept, and I can just move to the station number 1. So in that case, today we will use 4 different stations. We are in the very close range, so it's not an open area, but it's just to show you live this possibility and how to calculate that live on field. We will start from the station number 1, then we will measure the station number 2 on your left side, then the station number 3 and the station number 4. Okay, so now we already created the job. We need directly to select the correct instrument. So in that case, we will use a Zoom 95. You can also see from the Bluetooth that we are using the Bluetooth long range handle. Then survey, and just start with a station setup. Oh, thanks, Francesco. The GPS is already leveled.
Yes,
sure. Okay, now as usual, we have different possibilities to start the job. If we know the station position, we can use one of the 2 functionality that you can see here from yes. Okay, so backside to no point, and the station is positioned on the no point, backside by azimuth, orientation to multipoint, or backside to no point and travel. We will see then this functionality from the station number 2. So in that case, we can directly select backside by azimuth. Next, the ST001 is our starting station. I also know that we measured the elevation of the TPS, so we can enter in the instrument height from slant elevation, and here we can select the correct elevation.
1.483.
Thanks, Francesco. Here we are. As you can see, the elevation is already recalculated by the software. Then the position could be 100, 100, but also you can choose a different local system. Next, by azimuth. Now we can also select circle or store backside point. So in that case, I don't need to store the backside point, so I can deselect this option and move forward. Okay, next, in that case, it's not a run prism, but it's a reflectorless mode. It's ready?
Yeah.
Okay. Just remember the backside for the next one.
This is a very important point,
Exactly.
Andrea. When we will detect the station 1 to close the loop, we will need to orientate on the same place.
Exactly. Basically, it was the example number 1 that I showed you before. Then we can click directly on measure and accept setup. Okay. So station setup is already completed. Now we can move directly to the survey points menu. We can change to round prism. So in that case, we'll use only the round prism, and the elevation of the target is 1.526. Perfect. Okay, we can directly lock the prism with a continuous. Okay, now looking for the prism. Okay, the prism is already locked. It's not a direct measurement. There's another option from the survey menu. We can directly click on direct measure, and then we can switch to traverse points. So automatically, the name of the point will move to ST002. So in that case, we don't need to name the new station, but we can directly select measure and store. So the station number 2 is already calculated, is already measured. So as I told you before, the 2 different ways to create a closed loop traverse is, in that case, do, for example, the first example is to measure the station number 2 and continue till the station number 4, then reposition the TPS on the station number 2, same orientation with the same backside orientation, and then measure the station number 4. The second example is from the station number 1 to measure the station number 2 and also the closest station, that in that case is the station number 4. But of course, in field is difficult to have also the closest station, so we can directly move with a classical example. So now we can remove the TPS from the station number 1. Look, I can also unlock the prism. Okay, perfect. In the meanwhile, I will move the round prism from the station number 4 and put it on the station number 1. So here we are. The round prism on the station number 1. Okay. Now I will move close to Francesco, and I can show you how to do now the orientation at the different level. So station setup. Now we already switched the station on the position 2, so on the station number 2. We can select the new setup. So in that case, the position of the station is already known. So I can select yes, next. So in that case, we can select backside to no point and traverse. So next. Here we have two different measurement order. And I can directly show you that. Backside 1, foresight 1, foresight 2, backside 2, or backside 1, backside 2, so phase 1 and phase 2, forward side 1, foresight 2, so phase 1, phase 2, also to the next point. Honestly, I prefer this one because I don't need to move too many times the TPS. We can also select a measure in phase 1 and phase 2, just to have a more precise calculation. How to aiming for the prism. Honestly, I prefer this to leave this option activated. Accept. Now, this is the station number 2. I can select it from the traverse point, so ST002. I can modify the elevation from slant height 1.526. Okay, thanks, Francesco. Accept. Next. And here we need to select the backside points. So click on the arrow, traverse points, ST001. Next. Now we need to select the height of the prism, and here XPAD will show me also the latest height used. In that case, the station number 1 was 1.483. It's not listed here because it's calculated the slant height for the TPS, but then with the next point you can directly see the list. Okay, 1.84483. Okay, is in auto aiming, so you can see also the icon here, aim 360. So you can directly click with a long press to auto aiming the points while aiming the prism, or select aim 360 and select lock. So it's already locked. Now we can directly measure. So in that case, from the station number 2, we will measure in phase 1 and phase 2 the station number 1. Okay, as you can see there, now the next point is the ST003. So XPAD automatically recognizes that we are creating a traverse, and then from here we need to lock the prism on the ST003. The prism is already unlocked from the station number 1. Francesco already moved it to the ST003. We need to change the elevation from the target on station number 3. It's 1.468. Perfect. And now we need to measure it. So again, let's measure it in phase 1 and phase 2. So automatically the GPS will rotate towards the point, measure in phase 2, and then again return to the phase 1. As you can see there, we have the result of this traverse. Still here, you can also see the difference result for the delta angles, the delta distance, and S north and elevation. In that case, the tolerance, also the standard deviation from the backside in terms of horizontal or vertical angle and slope distance. Okay, upset setup, and then automatically XPath asks us if we want to move to the foresight point, so to the station number ST003. We position the prism on the station number 2. I can say yes, I want to move to the station number 3. And in that case, again, I need to enter the elevation for this. Again, height from a slant height, and now select the slant height of the point. Choose 1.468. Okay, accept it. Automatically is calculated with a elevation difference between the target's ground prism and the TPS height. Next. Now the backstart point again will be the station number 2. So ST002 will become automatically next. And now we need to select the elevation from the station number 2. So in that case, it is already listed here. Is 1.526. Okay. We are close to the prism. I can select directly long press in 360, and automatically TPS will lock the prism. So as I told you before, now we can measure directly the orientation, so the ST002 in phase 1 and phase 2, because we already selected this option. Now the TPS will return to the original position, so to the phase 1, and then we can directly move to the ST004. Icon to automatically lock the prism and measure it in phase 1 and phase 2. Okay, so we are ready here to the station number 4, upset setup, move to the foresight point ST004. Yes. Okay, so in that case, you can help me. Directly switch from ST003 to S3004, and that being also the prism from station 4 to the station 3. Help me. So let's just be faster. Okay, now the elevation on the station number 4 from slant height again is 0.67567. Sorry. Offset. Next, ST003. So this is automatically. Next. Okay, I can also search for the prism, select it, I need to enter the elevation of the target number. So in that case, 1.468, which is listed here. Phase number, phase 1, phase number 2, and then back to the position. So in that case, the TPS automatically asks me if I want to measure the S300. So in that case, the traversal on the right-hand side, you can write S305. Otherwise, you need to load the traversal at the training using the first station. So in that case, you can directly select ST001, lock the prism, changing the elevation of the target on the ST001, 1.483. Is in the list of last year's target measure. Now, overwrite point or additional measure. So in that case, we don't need to overwrite point, but we need to create additional measure. And here you can also find, okay, wait, you are measuring a point, an existing point. So you want to measure it, so you are sure, you want to overwrite or measure an additional measure, create an additional measure, or you need to move to the next point, additional measure. Okay, so we have only an elevation error of 4 millimeter. I can accept the setup. So, do you want to occupy the foresight point with a new station? I can also select yes or no. So in that case, what we need to do is to move again the TPS on the ST001, use the same orientation, so the backside orientation to the same point. In that case, just because we use the backside point orientation. So this is very important because we must use the same orientation of the original ST001. Otherwise, the calculation is very, very wrong. Up station stop. In that case, I need to select new setup. Yes, the station position is known. Backside by azimuth. ST001 from the traverse point. From length height, need to enter the 1.482. So next. Again, I don't want to store the backside point, so I can deselect it. Here in the decrease, the backside point, yes, next. Is not a prism, is a reflectorless point. Measure. So this is just because we need to use the same orientation of the original station. So accept the step, and then from the survey points, we need to measure the ST4, and that is the closing point, traverse point. In round prism, we are selecting the correct type, which is the listed here, 567, so 56. Lock the prism. Let's lock it and measure. Oh, sorry. We need to call it ST4. So with the same name, otherwise we cannot close the traverse. And from Jordan store, again, additional measure. Just because we need to measure the same point, the same closing point, also from the opening station. And here you can see a delta errors. So in delta in elevation, distance and elevation, just because we are using a different tripod. So we strongly suggest you to use the wooden tripod and not the aluminum tripod for the traverse, just to have the best calculation, just to have also the best calculation in terms of tolerance.
Plus, we have to say that this surface, Andrea, is made from small bricks that are floating on sands. So all the cars that you have seen are moving in this parking place. Anytime move a bit
Also
the surface.
our
yes, exactly. But by the way, as an example, it can be really helpful to understand the procedure and how to proceed.
Also, how to use the best tools to perform this activity.
Yes, that's
Accept. In that case, we already performed we already closed the traverse. So how we can calculate now the traverse directly on field? We need to move to the cargo menu. From the cargo menu, we have the traverse calculation option. So here, available TPS station. I can click on the arrow, and then you can see that, for example, if your starting station is not the ST001, you can directly select the correct station from the list, select directly plus, and now we can add the TPS. As you can see there, we have two different options. If I click on the arrow, it's already show me the two different options. The first option is the ST004 or the ST002. So I will directly select the ST002 plus, and XPAD automatically calculated me the other station close till to the closest station. Here you can directly visualize a preview from the card of all the different segment length, the number of the station is 4, the length is 76 meter, 0.717. Okay, next, and this is how we can decide how to calculate the error. So from angular error, we have the coefficient square. Here we can enter the coefficient value, and the distribution mode is only in that case vertices. So we can distribute the angular error only through the vertices. Then linear error. Here we can decide if we want to select a fixed value. So for example, you can also select the tolerance or the coefficient to distribute the error in the linear mode. So also the distribution mode can be through the vertices or through the traverse length. So we can distribute directly on the 4 different vertices or along the traverse length. Elevation error, in that case, only fixed value, because we can only calculate through the fixed value. And here we can also set the tolerance. So we can increase or decrease this tolerance, deciding the accuracy that we want to reach. Based of the it depends on the accuracy that we want to reach. Then distribution mode, vertices, or again on traverse length. So if now we select calculate, you can see first of all the traverse data. So the traverse type is a closed loop traverse, length, the vertices count, plus the linear error before the angle balance. So in that case, the linear error was 9 millimeter. Also, you can see a result of the tolerance, so also of the elevation error. Angular error is calculated in degrees. And then linear error after the angle balance. So in that case, you can see that using the incorrect tools, like for example, the aluminum tripod, but also a floating pavement can affect also the traverse calculation. And then we can directly move to the next. And in that case, it's suggesting us how to continue with the survey. So we can directly back up the job and overwrite the data, or we can directly simple overwrite the data. Usually, I prefer the first option. So adjust traverse and create a copy of the job. This copy of the job will be directly saved in our site folder. Okay, traverse calculation completed successfully. Okay. So now, as you can see there, the job is traverse live. If I select job, open job, we can also have the copy traverse live. So a copy of a backup of the job. Okay, so the main difference, as I told you, the main difference between a closed loop traverse and a closed traverse is that a closed traverse is not completely closed. So from the station number 4, we don't need to measure the ST001, and on reverse, so from the ST001, we don't need to measure the ST004, but we must have 2 reference points. So the first one at the start station, so ST001, and the other one on the ST004. This is because we need to fix in somehow the traverse calculation through a reference point. So that can be measured before the job, or that can be imported also from another side. Okay, so if you have any question, please write us on chat. We are, of course, at disposal also through our website, but also through our email, academy.geomax-positioning.com. Feel free to ask us everything, and you will receive the videos of this webinar in 2 days directly from the registration email, and this video will be also published on our website.
So Andrea, I think we can close the webinar.
As you can see, if BTS will come in your site during the survey calculation, during the survey of the products, you will have some additional error.
Exactly. So thanks a lot for your explanation, Andrea. Thanks to you guys for the participation. I hope to see you to the next webinar live. Thanks, Andrea.
Thanks to you, Francesco, and thanks to all the participants.